analyze the program? Nope, does not, right? So that's why you want to preserve as much information as you can as you go from the precondition to the post condition. Are we doing okay so far with this example? Okay, so everybody understand why we want to carry that one extra step, so that when you know that something is a constant, you want to just propagate a constant to everything that mentions the variable itself. All right? All good? All right. So after this, we talk about self-referencing. We talked about this a little bit last time. We talked about function versus the inverse function. One is to do something, the other one will undo something. So the question now is, how do we make this a general approach? Whenever I see something that looks like this, is there a mechanical procedure that I can follow so I can go from the precondition to the post-condition? Because that would be a good thing. Otherwise, we'll be looking at this on a case-by-case basis, which is a little bit less convenient. We want something that's convenient. We look at the expression, we look at the statement. Whenever we can apply a mechanical procedure to go from the precondition to the post-condition, we want to be able to do that. So that's what we'll do next, is to take a look at an example like that. Okay. So let's say this is somewhere within a program. Let's say this is line 57. We're 57 lines down from a program, from an algorithm. And we have a statement that looks like this. Okay, y gets y minus 1. Okay, that's our statement. So we already know what to do with this, but we want to find out how do we mechanically do it. So in this case, I have to give you what is the precondition of line 57, because otherwise you wouldn't be able to do anything about the post condition. So the precondition of line 57 is something like, let's say y is less than z, and 2 times y plus 10 is greater than k. Okay. Don't ask me why, because that has to do with the 56 lines before this, or if this is in a loop, it has to do with all the statements after that too. So we'll deal with loops later. Okay, loops are very interesting when it comes to figuring out the pre and post condition. Okay, so we don't know why, but we can say that, okay, but that's the precondition. Before line 57 executes, we know that this condition has to be true. I don't know what exactly is. I don't know the value of y, z, or k, but I know this relationship is always true whenever I'm ready to execute line 57. So the question now is, what do we do to derive the post condition of line 57? Last time we already talked about how to undo the effect of line 57, so that we can say, well, we know that line 57 is going to change y, but if I can reverse y back to the value, if I can figure out the value of y before the statement, that relationship will still be true. So we understand the principle. The question is, how do we do this mechanically? So in this case, what we want to do is, first of all, we say the right-hand side of line 57 refers to the left-hand side. Okay. Now this gives us a possibility that we can apply the substitution rule instead of the forget rule. Not all the time, but this gives us a chance. Okay. So the next thing we want to do is to say the right-hand side of line 57, and I'll give it a name, a function, f of y is y minus 1. In other words, I just take whatever is on the right-hand side, in this case it is y minus 1, and make it, quote-unquote, the function that we are dealing with, so that we can refer to the inverse function, how to undo this operation. Okay. Has an inverse. So if f of y is y minus 1, what is the inverse function? I just called it f prime here, which has nothing to do with derivatives. I'm just using the prime symbol to mean the inverse function because it's just easier on me on the keyboard. So the inverse function of y in this case should be what? How do I reverse the fact of subtracting 1? Just adding 1, right? So this is y plus 1. Now, when you think that something is an inverse function of something else, you can always verify it. You can always double check and say, well, can we be 100% sure that this in fact is the inverse function? The answer is yes, because you can apply the inverse function to the function to whatever is inside. Okay, I'm just picking y here, but it doesn't have to be y, it can be x, can be k, can be whatever. Okay, what is that? Well, first of all, we can apply, well, let's go ahead and deal with f of y first. F of y is y minus 1, so this becomes that. Is that okay? I'm taking this part here, and according to this definition, I'm expanding it over here. So the next thing is to say, okay, now that we know we want to apply f prime to the value y minus 1, what does that mean? It means we take whatever is inside the parentheses and just add 1 to it. That's from the definition of this part here. So if you remove the parentheses and change the operation a little bit in algebra, we can know that this is the same as y. Is it okay for me not to go through all the steps in algebra to come to this conclusion? It's all right? Okay. All right. So this, I have just verified that f prime is in fact the inverse of f. Now, this is great, okay? Because an inverse exists, apply the substitution rule. I just call it sub-rule. Okay. The substitution rule goes like this. The post condition of the line that we are dealing with is based on the result of substituting something with something else from the precondition. So we'll start with the precondition, and then we say, whenever we see any mentioning of variable y, change that to f prime applied to y. Okay. What are we doing exactly here? Well, we are basically saying we know what line 57 is going to do to the variable y. But in order for the relationships already stated in the precondition of line 57 to continue to hold, we cannot just say that y is still relating to all the other variables the same way as before, because we just changed it. On the other hand, if we figure out a way to reverse y or have an expression to come up with the value of y before it got changed by line 57, hey, you know what? All those relationships that we knew about y and all the other variables before, they would still be true. So this is what it's doing here. It's just saying that we are going to undo the operation of line 57 so that we can maintain the relationships. So in this case, I will spell out what is the precondition of line 57, and I can kind of cheat a little bit here because I have an editor. And then I'll also expand f prime of y. F prime of y is y plus 1, and I will say y plus 1, but I'll put it in parentheses just so that we can do a text substitution without having to worry about the precedence of operators. Because if I have multiplication and stuff like that before, like in this case I have 2 times y, if I do not use the parentheses, then 2 times y plus 1 is ambiguous, right? But if I use parentheses, it is very clear that we have to add 1 to y first, and then multiply the whole thing by 2. Okay, so let's go ahead and continue with this. So the substitution operation is really just substitution. It means we take whatever we have here. Every time we see y, we change it to y plus 1. Every time we see y, we change it to y plus 1. It is literally replacing y with y plus 1. Are we doing okay so far with the substitution operation? Is it mechanical? Extremely so. And that's the way we like it. Because if it's mechanical and there's a template, you can just say, okay, which one does it fit? Should we apply the forget rule or the substitution rule? And then once you decide that we have to apply the substitution rule, you just have, the only part that is not mechanical is to figure out the inverse function. You had a question?
So to apply the sub rule, there has to be an inverse, right? Is that the only condition, or are there other occasions where you can use a sub rule?
There are other occasions where the sub rule cannot be applied, but you can still derive the post condition from the precondition, except it's not a simple substitution. With anything that has an inverse function, the substitution rule will take care of it. Okay, but if it is not an inverse, then you have to think, okay, is there anything I can still kind of salvage from the operation? I'll give you one example that kind of illustrates why we cannot use the substitution, but you can apply some other operation and still be able to make a conclusion out of the whole thing. Okay. That's a very good question. Any other questions at this point about the substitution operation?
It's probably not a good idea to go ahead and solve that out, the latter equation, 2y plus 1.
There's
You
no
wanna keep
need
it
to.
2y plus 1.
There's no need to carry out any simplification or expand it at this point. If you want to, it's not too bad, because in this case it's just 2y plus 12 is greater than k, which is okay. I mean, it doesn't add or subtract any information. So I wouldn't do anything until it is necessary. Yep.
So that's the final answer?
Yep, that's the final answer.
I thought you said wherever there's 1, we do y plus 1.
Hmm?
Then you finish up for the latter half.
The other half?
Simplify it over
Sorry?
last line.
The last line? I didn't finish the whole thing?
You didn't simplify it, or you didn't
No.
distribute?
No, there's no
You
need
don't
to
wanna
do it.
distribute the two?
That was the question earlier, is do we have to do anything after this? And I would say no, not. It doesn't buy you anything. It doesn't buy you anything at this point. Now simplifying may be helpful later, but until we actually can make use of the simplification, I would just delay that. Especially in this class, we are not focusing so much on the algebra portion. We are focusing more on the meaning of the pre and the post condition. All right. So is that okay so far? Okay. All right. So let me go ahead and give you another example where an inverse function doesn't exactly exist, but we can still make use of it. Okay. So this is kind of like extra material. Okay. Not to be included in any exam. Since this is now recorded, if I ask any questions about this, you can say, Tech, but you said you would not ask any questions like that in the exam. It has to be extra credit now. But that's partially why I make the screen recording, is so there will be no dispute of any kind. Right? All right. So what we want to do is to say, let's pick another line 81. So line 81 says, x gets x times x. Okay? So x squared. And in this case, let me throw a curveball at you and see whether you can, deal with this one. So in this case, I'll tell you the post condition instead of a precondition. So I'm going to give you the post condition and say that post condition is x is greater than, I don't care, 79, 78. Okay, and it's that. It's just that simple. All right. Well, we have to deal with two things now. Okay, one is, why are we going backwards? What is the realistic application of given the post condition and then going back to the precondition?